So this is an overview diagram of DES encryption. So at the plain text side, there are 4 operations are done. One is initial permutation, that is step 1. Second, round function operations. So totally 16 rounds are available. Each round, different subkeys are used. Then we should use a 32-bit swap. After that, we should do inverse initial permutation. Then only we can able to get a ciphertext file. So this is at a plain text side. For generating 16 different subkeys, so initial key is also a 64-bit key. For reducing 64 into 56-bit key, we should use permuted choice 1. Then for generation of different subkeys, we are using left circular shift at each round. Then for reduction of 56 into 48-bit key, permuted choice 2 will be used. Then now, how these inverse initial permutation permuted choice are done. We just give the overview idea. So initial permutation. So totally 64 values are available. So we should store those 64 values in a 8 cross 8 matrix. So totally 8 cross 8 contains 64 values. So the continuous values are from 1 to 64 bit. So it is a plain text. So the plain text contains continuous 1 to 64 bit values. So you should store these values in 8 cross 8 matrix. The order is you just store the odd bits, that means 1, 3, 5, 7 at the lower columns. That means it is row 1, 2, 3, 4, 5, 6, 7, 8 rows. We just store the odd values at the last 4 rows from the last column onwards. So just check it out, 1, 3, 5, 7, 9, 11, 13, 15. Like that, the odd values means up to 63. The bits are located from last column to first column. Then the even bits are 2, 4, 6, 8. Then 10, 12, 14, 16. The same way. In which way the odd bits are stored, the same way the even bits are stored from the last comma onwards. So 64th bit is stored at the row 4. So it is an initial permutation. Permutation means transposition. So I interchange the values of 1 to 64 bit of continuous plaintext into row order. So this is the first round. That means this is the initial permutation round. After that, the bits are varied. So you just find out in row order, read in a row order way. So initial permutation is done. Then inverse initial permutation, that means after the 32-bit swap, we should do inverse initial permutation, which is also called as final permutation. So the final permutation, that means after a 32-bit swap. So this final permutation is done after a 32-bit swap. So after a 32-bit swap, those 64 values are stored as, so you just check the second column. In the second column, I am storing the continuous 8-bit 1 to 8. Then fourth column 9 to 16. Sixth column 17 to 24. Eighth column 25 to 32. Then the remaining values are stored at odd columns from first column onwards, from bottom row to top row. So this is the final permutation, and this is the answer of ciphertext value. So this initial permutation and final permutation is done at the left part. So the left part is a plaintext part. So what are the remaining portions? Second, round function operation and 32-bit swap. So how this is performed? So this is the next question. So totally 16 rounds are there. This diagram shows a single round function. So the same set of round function is performed in all 16 rounds. So totally 64-bit plaintext are available. So the 32-bit are plaintext. So total plaintext is 64 bits. It is divided into left part, right part. So L denotes the left half, R denotes the right half of plaintext. So 32-bit, 32-bit. Then we should do the round function operation. So F means round function, which contains 4 basic operations: expansion, XOR operation, substitution, permutation. So this continuous 4 operation is called as round function. This round function is done only at a right part of plain text. Just remember it. The round function only performed at right part of plain text. Then the resultant answer is shifted to left part. So this is the round function answer. This round function answer is once again XOR with the left part and it will be switch over to the second round. So for example, it is taken as first round. So if you take I is equal to 1, I means first round. So the value is L0 or 0. So you are doing round function operation. Round function contains 4 operations. That means expansion, XOR, substitution, permutation. The answer is there. Once again, the answer is left half with L0. Then it will be given to right half. Then what is the L1 part? L1 part is nothing but the same R0 value. So what is the right side 32-bit value? That value is given to the second round. So this is the second round operation. Once again you do round function operation at right side and you do XOR operation with the resultant value. It will be given to right 2. So what is your L2 part? L2 part is your R1 value. So like that totally 16 rounds will be performed. And here C and D is called as key. So at the key side, the initial 64-bit key is changed into 56-bit key by using permuted choice 1. Then we should do left circular shift operation. Then after performing permuted choice 2, it will be changed as 48-bit. So this is the operation. So the diagram shows this after PC1. So the 56-bit keys is after permuted choice 1. The key is also divided into two halves, C part, D part, and left circular shift is done at individual part. That means at left 28-bit part, the left circular shift will be done. At the right side, right half side also, left circular shift will be done. Then it will be combined. Combination means total 56 bits are available. Then by applying permuted choice 2, that is permutation contraction. It is shortly say that permuted choice 2. So this is the reduction format. Reduction means 56-bit value is reduced to 48-bit. So that only the diagram shows like this. So 56-bit key, from the 56-bit, 48 bits are used for XOR operation. So here this is the sub key. So if I is equal to 0, 1, the first round means the first is K1 contains 48 key that will be generated from the total sub key 64, total key sub key 64 bit. Then round function first operation is expansion. Expansion means here 32 bit. So the 32 bit should be expanded into 48 bit. Then XOR operation means XOR operation is done at right part of plaintext with key. So the size of plaintext and size of the key should be same. So the answer is also 48 bit. This is the second operation. Third operation means S-box substitution, in which the 48 bits are reduced into 32 bit. So the reduction diagram is drawn. Then we do the permutation, that means shifting of bits values. Permutation is done. So this overall 4 operation is called as round function. Then at last we should do XOR operation. So here we can say that, so this is L0 R0. Here it is L1 R1. So in the diagram we can able to write it as, what is your L1? L1 is retrieved from R0. And what is R1? R1 is L0. So this is the L0 value. It is XOR with your round function. For the round function you are taking R0 value and K1 value. So this is for round 1. After round 1, the answer is like that. Same thing is used for 16 values also. So we can able to generally write it as I means that particular round. So Li is equal to Ri minus 1. Okay, correct. So it is, if it is 1, you retrieve from 0. If it is 1, you retrieve from 0. So I write it in a generalized form. So Li is equal to Ri minus 1. So Li equal to Ri minus 1. Ri is equal to Li minus 1 exclusive R of round function of Ri minus 1 comma Ki. So from this diagram, we can able to write the encryption process. And the round function contains 4 operations: expansion, subkey XOR operation, subkey generation, permutation. So this round function operation explanation will be given in next session. Thank you.